Hi all, I am Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Topic is Photochemical Milling. In short, it is PCM. At the end of this session, student will be able to understand the procedure of photochemical milling. Okay, so this one. So usually non-traditional machining process has divided or classified into three main categories: mechanical, thermal, chemical and electrochemical. In mechanical, ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. In thermal, electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. In chemical and electrochemical, chemical milling, photochemical milling, electrochemical machining or milling. Okay. Right. Now let us discuss photochemical milling. In short, it is PCM. Photochemical milling is a variation of chemical milling where the chemically resistant mask is applied to the workpiece by photographic techniques. So here the technique is photographic technique. Okay. So what we are using in chemical milling? Mask. Okay. So here also we are using the chemically resistant mask. Okay. The two processes are quite similar because they both use chemicals to remove metal by the CD action, and some of the steps required in both cases are similar. Okay. Right. CHM is usually used on three-dimensional parts originally formed by another manufacturing process such as forging and casting of irregular shapes. Okay. So here chemical milling is usually used on three-dimensional parts. That means solid parts formed by another manufacturing process such as forging and castings of irregular shapes. Okay. So here both chemical milling and photochemical milling operations are almost same. The steps or the procedures may be same. Okay. Right. As with photochemical machining, areas not to be machined are masked from the CD action of the chemical solution. CD action means chemical dissociation. Okay. Right. Photochemical machining therefore creates new parts from thin materials rather than simply smoothing or altering parts formed by other manufacturing methods. Okay. Photochemical machining creates new parts from the thin materials rather than simply smoothing or altering parts formed by other manufacturing methods. The process is sometimes called photochemical blanking, PCB. Okay. Since flat, thin gauge complex parts can be machined to high precision in thickness ranging from 0.013 to 1.5 millimeters. Sometimes photochemical machining is used to surface etch components with lettering or graphics where the etchant works its way to only a certain depth in the material. Okay, so here what could be the range? 0.013 to 1.5 mm. Okay, so here thin gauge complex parts can be machined to high precision in thicknesses ranging from 0.013 to 1.5 millimeters. You can imagine how less the thickness is. Okay, as in the case of chemical milling, the depth of etch is controlled by the time a component is immersed in a particular etchant. So how much time that we are etching, okay, that is a parameter here. Okay, in the case of chemical milling, the depth of etch is controlled by the time a component is immersed in a particular etchant. Okay, how much time that we are immersing for the particular etchant. Okay, sorry, in a particular etchant, right? Neither photochemical machining nor chemical milling should be confused with photo forming, PF. Okay, which is the process of electroplating metals over a mandrel. Okay, so that is the difference between the photoforming and photochemical milling or normal chemical milling. Okay, the photoformed components are removed from the mandrel after the proper thickness of material has been deposited. Okay, the photoformed components are removed from the mandrel after the proper thickness of the material has been deposited. Now look at this process description. Okay, so this is the PCM flow diagram. Okay, right, PCM means photo chemical milling, PCM. Okay, right, figure 2 shows the flow diagram of the PCM process. Now look at this. Part drawing or CAD data, that is the input. Next, photographic processing, photo tool, and here metal selected and cleaned, photoresist coating, sensitized metal. Okay, so here photoresist stencil on metal and that it will be subjected for etching. Here photoresist stripping, final part. Okay, so one side the design and tooling part, the other side material and what is it called, coating and the sensitization of the metal. Okay, so these two processes are combining for the photoresist stencil on metal and it will be etched and photoresist stripping will be done. So finally the finished parts will be the outcome. So this is the PCM flow diagram. Okay, so here part drawing are CAD data. CAD data means computer aided design data. Okay, that may be in terms of two-dimensional drawings. Okay, maybe orthographic views. Okay, so photographic processing will takes place, okay, from that input data of the CAD. Okay, so similarly photo tool will be generated. Okay, that it will be the input for this stencil. Okay, right. The first step includes the production of the required shape on a photographic film or glass plate termed the photo tool. Okay, What is the first step? Production of the required shape on a photographic film or glass plate, termed as the photo tool. CAD, computer aided design, okay, artwork creates the required part shape which is used as the primary image of the photo tool. Okay, that's what we have discussed in the preceding slide. Okay, so here CAD artwork creates the required part shape which is used as the primary image of the photo tool. The sheet metal is chemically cleaned and coated with a light sensitive photoresist film. The photoresist will adhere to the part surface and act as a stencil resist, protecting the surface during etching. Okay, so here the sheet metal is chemically cleaned. So with chemicals, the sheet metal to be cleaned and coated with a light sensitive photoresist film. Okay, so after cleaning, a coating will have to deploy with very sensitive photoresist film. Okay, next the photoresist will adhere to the part surface and acts as a stencil resist, protecting the surface during etching. Right. The sheet metal is this permits the material to be etched from both sides, thus minimizing the undercutting of the photoresist and producing straighter side walls. Okay, so here minimizing undercutting of the photoresist and producing straighter side walls. The resist laminated or coated metal is then placed under the photo tool and exposed in a vacuum to an ultraviolet light source. This transfers the image precisely onto the resist. After developing, becomes a replica of the desirable geometry. Okay, so what we are doing here, we are exposing in a vacuum. Okay, so before that, the resist laminated or coated metal is placed under the photo tool and exposed in a vacuum to an ultraviolet light source. Okay, right. The exposed image is then developed by immersion or spraying. Okay, the exposed image is then developed by immersion or spraying. Each photoresist has its own developing solution, such as water, alkaline solution, hydrocarbons, or solvents. Okay, so here the solutions may be water, alkaline solution, hydrocarbons, or solvents. Okay, so here each photoresist has its own developing solution. So based on the requirement, we have to choose. Okay, so here the cost component and the quality component are the matter. The exposed material is then washed to remove the unexposed photoresist on the areas to be chemically etched, as illustrated by Allen during 1993. The imaged metal passes through the acid etch spray or dip, where it is selectively dissolved away. Okay, various etchants are available for different materials. Okay, various etchants are available for different materials. The right choice of etchant depends on issues such as cost, quality, depth of etch, and rate of material removal. Okay, the right choice of etchant depends on issues such as cost, quality, depth of etch, and rate of material removal. Okay, so we have to select as per our the requirement as we discussed just now. Now, figure 3 shows the main steps of photochemical machining. Okay, right. Here we have three steps in PCM. Okay, right. Photochemical machining. Right. Let us go with first one, A. The first process is metal clean. Already we have discussed. Okay, so the surface to be cleaned first. Okay, so this one, metal clean. So immediately after cleaning, what we have to do? Already we have discussed. Metal coated with photoresist both sides. Okay, so here both sides of the surface to be metal coated with photoresist. Okay, next what we have to do? Expose. Here photoresist negatives, these are. Okay, so here light should be exposed. Okay, and resist exposed through negatives, that is in double sides. Okay, this side and this side. Right. In C, resist developed here. So here resist has been developed. Okay, next here partially etched. See here, we can notice here partially etched. Okay, here at last fully etched. Okay, so this is the basic procedure for etching. Okay, right. After applying etchants by spraying or immersion, the parts are rinsed and dried. Okay, so after applying etchants by spraying or immersion, the parts rinsed and dried. Usually when we apply chemical, after the completion of the process, we have to remove all those chemicals by rinsing, and after that we have to make dry. Okay, next, protective resist is removed from machine parts with chemicals or with mechanical techniques along with chemicals. Okay, so in order to remove some chemicals, again we may use some other chemicals. Okay, which are not dangerous with the chemical reaction with the work material. Okay, right. So with this, let me conclude. So before conclude, let me reiterate certain important points. Photochemical. Okay, photochemical milling (PCM) is a variation of chemical milling where the chemically resistant mask is applied to the workpiece by photographic techniques. Okay, and here more or less the chemical milling and photochemical milling are similar in terms of its steps or basic operations. Okay, and important point is that chemical milling is used on three-dimensional parts. Okay, by forging or casting of irregular shapes. Okay, as with photochemical machining, areas not to be machined are marked from CD action of the chemical solution. Okay, and photochemical machining therefore creates new parts from thin materials rather than simply smoothing or altering parts formed by other manufacturing methods. The process is sometimes called photochemical blanking. Okay, this is important one. And here the sheet's thickness will be ranging from 0.013 to 1.5 millimeters. Okay, and here, as in the case of chemical milling, the depth of etch is controlled by the time a component is immersed in a particular etchant. Right here, not required. So look at here. One more time, let us reiterate these things. Part drive or CAD data. Okay, so that will be the first input from the design side, and metal selected and cleaned. Okay, this is the other side. Okay, so here the physical thing is focusing, that means material. So here the input is from computer aided design. Okay, either part drawing or CAD data. Okay, so from this photographic processing will be developed. So here, after cleaning of the metal, photoresist coating to be deployed. Okay, so photographic processing will in turn develop photo tool. Okay, so that photo tool is nothing but a template. Okay, so here photoresist coating will be done in this stage. After that, sensitized metal will be the output. So these two will lap one another. Photoresist stencil on the metal will be generating. So after that, etching to be done. Okay, so photoresist stripping will have to perform. So final and finished part will be generated at the end. So this is the PCM flow diagram. Okay, right. And already we have discussed these things. Okay, where we have discussed the metal cleaning and metal coated with photoresist both sides. Okay, so in the second stage, resist exposed through negatives double sided, and finally here resist development, so partial etching and full etching. Okay, so this is the photochemical milling process. Okay, right. So these are the various references associated to this presentation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.